All right. Hello everyone. So this is the question I'm going to solve it. It is based on capacitor charging and heat dissipation in the process. So question, I'm going to read it and explain it to you. Find the current through the battery as a function of time. Okay. Initially the switch K is open. So this is the circuit, and in this is the switch K. So this is the switch K. Alright. So initially switch K is open and S is closed, which is very realistic. Okay, circuit has to be completed, S has to be closed in order for this question to be meaningful. Okay, at time t equal to 3 RC, switch S is opened. At t equal to 3 RC, this switch is opened. That means after some time switch S is open and K is closed. Okay, calculate the heat dissipated in the resistors. Okay, after very long time. So I don't think you need the question anymore, so I'm going to be somewhere here. Okay, now so these are the formulas that I'm going to use basically. In general, in capacitor charging and discharging, this is what you need, right? So current as a function of time is Vs is source upon resistor, and this T upon tau is the time constant. And later on you will find out why this change is happening at only 3 RC. This question is set very elegantly, and we will see why. And the voltage of a capacitor varies with time. That means capacitor will be charging, its voltage will be increasing, right? And how does that vary? This source voltage into 1 minus this. Let's assume that source voltage is E for now. Okay, for now meaning for this case. Okay, so what happens? Let's analyze the first case. First case is K is open, right, and S is closed. All right, hang on, let me find. This is just great. So there would be some background noise. I don't have like background noise in a noise cancellation device, so I think it should be fine. Please focus on the question. And okay, so what happens? What circuit do you get in this condition? See, K is open, right? So this circuit is meaningless anyway. Okay, and S is closed. Now you have R and C parallel to another R and C. Okay, is this circuit not symmetric? Okay, so basically what essentially you have, if you solve it, what would be R equivalent only for this circuit, only for this circuit. Okay, you will get R by 2, and what is C equivalent? You will get 2C. All right, now these R equivalent and C equivalent are connected in series with this leftwards resistor R. All right, now what is final or R total? 3R by 2. I'm going to be quick. R plus R by 2. And what is C equivalent? That remains same. Okay, now what is, so we are going to find out what is the time, right? No, what is the current? Now tell me one thing. Current in this circuit, whatever current you are sending in, I total, all right, this is going to be just divided half and half, because resistor is the only region that is going to divide here. Half of the current will go to the upper branch, and other half will go to the lower branch. All right, so this is I by 2 and this is I by 2 here. Okay, now when you did this, just remember this, that if you want to calculate current in each capacitor, you will have to divide this I by I into half. So let's find out how current varies. So I'm going to use this expression here. See, this also has its own derivation, right? But questions demand is not that you can directly use these formulas. Okay, Vs source, I have assumed EMF of the battery E, and R is how much? 3R by 2 into e to the power minus t. Okay, wait, see, earlier I told you why 3RC. Okay, that will be clear here. So what is the time constant of this equivalent circuit? Time constant is RC. R is R total or C equivalent. R total is 3R by 2 into 2C. That is why 3RC has been chosen very, thoughtfully. It's not random 3RC. That's what I'm trying to say. T upon tau, that is 3RC. Okay, so what you got, 2E by 3R. क्या मिला आपको? 2E by 3R minus T by 3RC. Okay, this is I total. Now current in each capacitor, sorry, maybe I can put it here. Current in each capacitor, I told you that I1 as a function of time and I2 as a function of time will be equal, and those will be what? Half of this. So what will you get? E by 3R e to the power minus t by 3RC. So this is one of your answer. Okay, now tell me one thing. What would be voltage in each? See, capacitors are in parallel, right? These two branches are in parallel, so voltage will remain same. Okay, so what would be V time? That would be E. I'm again going to use that initial formula that I talked about, this one. Okay, V capacitor, V source is E, and 1 minus e to the power minus t upon tau. Tau will remain 3RC. Okay, so this is another voltage in the capacitor. Now what is changing at t equal to 3RC or tau? T equal to tau or 3RC. Let's put these values. What is voltage at t equal to tau? E 1 minus e to the power minus 1, right? And e to the power minus 1 is about 0.36, and this you will subtract. So I'm going to write this 0.632. Yes, I have used calculators, I cannot do it. Yeah, lost habit long time back. Okay, that is V. Fine, t equal to tau. Now after, so something is changing, right? Let me change my color as well here. Yeah, classical. Fine. So for t is greater than tau or t is greater than 3RC, what is happening? Switch K is closed and switch S is open now, right? What is happening? See the circuit. Now S is open and K is closed. Circuit is not completed, so circuit gets opened here, and see, these capacitors are in parallel, right? And they acquired same voltage. Right? When? For time greater than the time constant 3RC. Then would there be any redistribution of current? No, right? What I'm trying to say, capacitor will not be discharging, right? So why? Because delta V, there is no potential difference. Why would they discharge? Delta V equal to 0. So what would be current for time greater than 3RC? Tell me. 0, right? So these points are very important for the next part of the question. See, if there was some okay, I'll come to it. So next part of the question is calculate the heat dissipated in the resistors after very long time. Very long time meaning that will include time greater than 3RC as well, right? So so when does heat dissipation occur, right? So only during the charging, because after time greater than 3RC nothing is happening, potential difference is 0, there is no distribution of current, right? So all the dissipation will occur while charging of the capacitor. All right, so let me continue with that. So what we want to find out? Heat dissipation. Heat dissipation. Okay, heat dissipation, tell me one thing, heat dissipation, something that is lost, right? Dissipation means losing, like losing as a heat, or in this circuit of course thermal energy. So how can you find out in these kind of questions? Just use one thing, how much is the input and how much is the output, right? And whatever is the difference, that is lost, heat lost or dissipated, heat lost or dissipated, right? I can denote it with, let's say, q is the charge here, right? I cannot use q, so let me just h. Okay, so how much is the input, energy input, let me call it w, that is q total into v. V, when v is the final at time t equal to, so total potential transfer to the capacitor, right? And what is q total? Again q total is cv, right? C equivalent, right? C equivalent is 2c. And how much is v? V is e into 0.632. should I go back and remind you? Okay, fine. Here I'm going to take maximum potential that is transferred to the capacitor. All right, so to see this, so what is w then? 2c, and v is again here source, right? Source, so v is e, so 2ce square 0.632, right? You can multiply ce square, yeah, I can multiply this, 2 to the 4, 2, yeah, 12, right? 1.6264, fine. So this is the total work input or total energy input that you are giving in the circuit from the battery. But how much you got? Output meaning how much capacitors are holding the energy, right? Energy stored in the capacitors, right? That would be your output, right? Energy stored in the capacitors. Okay, that would be how much? Energy stored in the capacitors, half cv square, then c equivalent v square, right? And c equivalent is 2c, so 2 is going to cancel out. I'm going to write this, and v is how much? E into 0.632 whole square, and v square is c square, right? So when you'll square it, I think, if I'm incorrect, just correct me, 0.4, right? Something like this. And now heat dissipated would be input minus output. Output is, let me call it E, right? Final energy stored in the capacitors. So this is C square 1.264 minus C square 0.4. So you will get C square 0.864. Okay, if values are given, you can estimate final one also. So this was a good question. So one answer is your this. Okay, this is an answer. Where is the rest of them? Yeah, you can say this is also sort of one of the answer, this is one of the answer, and this is another answer. Okay, I hope you can it was not that long, right? It's very small question, fine. So thank you so much for watching the video. You can give your feedback in the comment section, and yeah, you can ask your question through my Telegram channel. I may not be able to solve it immediately, but I will try to do my best. Thank you. Let me stop the video.